Of the three periods of the Mesozoic era, the Triassic period was easily the weirdest. Dinosaurs had just evolved, and the world was filled with a variety of other reptiles. Some had incredibly long necks, others flew with their legs, and a few even had domes or horns millions of years before they evolved in dinosaurs. One of the oddest Triassic reptiles was Vancleavea, an aquatic reptile which looked like a strange combination of an alligator and an eel. Vancleavea wasn't just unusual when compared to the animals of today, but also possessed numerous features that set it apart from the rest of the Triassic fauna. Vancleavea has only been found in the southwestern United States in what were once freshwater environments. Its fossils were first discovered in 1962 by Philip Vancleave, for whom it was named after in 1995. However, it wasn't clear what it looked like until the description of two nearly complete Vancleavea specimens in 2009. Vancleavea fossils are found throughout most of the Chinle Formation, which spans about half of the Triassic period. This suggests it actually consists of several species, though only one, Vancleavea campi, is currently recognized. This is because most Vancleavea fossils are still fragmentary, making it impossible to confidently divide them into separate species. When Vancleavea was first found, it was so strange and incomplete that it wasn't clear who its closest relatives were. Now that nearly complete Vancleavea skeletons have been described, it is clear that Vancleavea belongs to the clade Archosauriformes. This is the clade that includes the dinosaurs, crocodilians, and a number of closely related reptiles. However, Vancleavea was very different from any other archosauriform. Its long body and neck were almost like a reptilian eel, with the addition of a crocodile-like tail and short legs. These legs were not quite vestigial, though their small size suggests Vancleavea spent very little time on land. The most complete skeleton is about 1.2 meters long. However, the largest fossils are estimated to have come from individuals nearly 4 meters long. Given such a dramatic difference in size, this practically confirms that there was more than one species of Vancleavea. Perhaps its most notable feature was its robust skull. The back was fairly long and boxy, but it ended in a short, thin snout. Several of its teeth were much larger than the rest, with one requiring a notch in the upper jaw to accommodate it. Vancleavea did not possess an anorbital fenestra, an opening in the skull between the orbits and nasals in most archosauriforms. Additionally, while most reptiles possess two temporal fenestra at the back of the skull, Vancleavea only had one large one. Compared to the other contemporary semi-aquatic predators, its snout was much shorter than those of the Proterochampsians and Phytosaurs, but thinner than those of the large amphibians such as Anasacchisma. This suggests Vancleavea used a different strategy than them when hunting, allowing them to divide the resources of the Triassic rivers and lakes between them. However, it is still not clear what Vancleavea ate or how it caught it. As mentioned before, Vancleavea's tail was very similar to those of crocodilians. It was tall and flattened along the sides, allowing it to be its main source of propulsion underwater, compensating for its short legs. However, unlike crocodilians, only the bottom half of its tail was supported by its tail vertebrae. The upper half was instead formed by tall, flattened osteoderms, pieces of bone that grew within the skin. While osteoderms were fairly common among archosauriforms, and are even still present in crocodilians, using them to lengthen the height of the tail is very unusual. The rest of the body was also covered with osteoderms, with at least 5 total variants. Their shape depended on where they were on the body. Besides the osteoderms at the top of the tail, the osteoderm variants were divided between the belly, throat, limbs, and the rest of the body. Osteoderms similar to small stegosaur thagomizers have also been attributed to Vancleavea, although it is unclear where they were on its body, or even if they truly belonged to it. Since the spikes are absent in the best preserved specimen, it has been suggested they instead belonged to a species of heavily armored aedosaur. However, if Vancleavea consisted of multiple species, it is conceivable that their osteoderms may have differed from each other. As for where Vancleavea fits in Archosauriformes, it wasn't an archosaur, meaning it was not a descendant of the last common ancestor of the dinosaurs and crocodilians. However, it was more closely related to the archosaurs than basal archosauriforms such as the Litorosuchus or Erythrosuchids were. Although Vancleavea was once assigned to the clade Proterochampsia, the discovery of Litorosuchus in 2016 instead suggests it belongs to its own, unique branch in Archosauriformes. Litorosuchus was a marine archosauriform from Middle Triassic China. It is Vancleavea's closest known relative and serves as a transitional fossil between it and the rest of the more typical archosauriforms. For instance, Litorosuchus is currently the only other known creature that heightened its tail using osteoderms. On the other hand, its snout was long, and it still retained its anorbital fenestra. So while the picture of Vancleavea's evolution is starting to come into view, it still remains distinctive from all of its contemporaries. While there is still much more that remains to be learned about it, what is known about Vancleavea illustrates just how strange the Triassic period really was. Thank you for watching. I hope you learned something interesting. Have a great day, and if you enjoyed the video, please remember to hit the like button.